Okay, continuing with the Nelson College Maths and Stats exam for Level 1, investigate relations between tables, equations and graphs. We're now looking at question 2. In question 2, Lola has a small pet lamb which she has to keep separate from the bigger animals on her farm. She has 50 metres of fencing that can be used to make a rectangular enclosure for her lamb. What is the largest enclosure Lola could make from her 50 metres of fencing? Investigate different sized rectangular enclosures. It's very important when a question asks you to investigate that you do an investigation. So we want to try different possibilities and make a conclusion. That's what we need to do for our investigation. And they want us to record each step of your investigation clearly. So, just a little sketch. Lola's going to make some sort of rectangle out of her 50 metres of fencing. Now remember, I want to use a table, a graph or an equation, so I'm thinking about using x for the width of my rectangle, which means the length of my rectangle must be 25 minus x, so that 25 minus x times 2, the two lengths, plus 2 times x equals 50. And if I was to solve this, I'd find it was 50 for any value of x. So I could use a table and try different values of x. So if x was 0, then the area obviously would be 0. If x were 5, then the length would be 20 for the length, and the area 5 by 20 would be 100 meters squared. If x were 10, then the length would be 15 and the area would be 150 meters squared. If the width x was 15, then the length must be 10, and I would find I get 150 meters squared again. So there's some sort of symmetry going on here. When I get to 20 for x, again the area would be 100 meters squared. I've effectively just turned the rectangle on its side there. So there's a table for my investigation, and I've tried different sizes, and it looks to me like somewhere in here I'll get the maximum area just with the symmetry. So I'm going to try 12.5, being halfway between 10 and 15. Now in the original question it never said she had to have a whole number of meters on one side, so it is possible to have 12.5. When x is 12.5, L would also be 12.5, 25 minus 12.5, which is 12.5. She's effectively got a square. Now a square is possible, a square is a rectangle. When it's 12.5 wide and 12.5 long, it's 12.5 squared, and 12.5 squared by 12.5 is 144 plus 6 plus 6 plus 2.5, no sorry, plus 0.25. 144 plus 6 plus 6 plus 0.25, which is 156.25. 156.25 meters squared. Now remember, we can't use a calculator. Oh yes, we can use a calculator for this standard, sorry. So I could have done that with my calculator. So my conclusion, Lola could make a square enclosure of 12.5 meters each side and area 156.25 meters squared. So that was using a table. I've also got the possibility to use a graph. My equation, the area is the length times the width, so x times L, which is x times 25 minus x. This is going to give me a parabola, and with the negative x squared going on here, it's going to be an inverted parabola. something like this. So let's look at the y-intercept. That's when x equals 0. When x is 0, I've got 0 times 25, so a equals 0. It's really the a-intercept, isn't it? My axes being area and width. Now, what are the x-intercepts? The x-intercepts are where the area is 0. Well, the area is 0 if x equals 0 or x equals 25. So, on my graph, 0, 25, I've got two x-intercepts like that. It's inverted. I know that my vertex for my parabola must be halfway in between, so it must be on this line x equals 12.5, being halfway between the two x-intercepts. So I'm going to substitute that back into a, and it's really just the working I did before. A equals 12.5 times 25 minus 12.5, which is 12.5 times 12.5, which equals 156.25. So my parabola looks a bit like this, and I've just arbitrarily chosen my scale so that that's 156.25. So here I've used initially a table, which I could have done, or separately I could have used the equation in the graph. Remember the standards about using tables, equations and graphs? With my graph I've found the same conclusion. Okay, Lola makes a square of 12.5 meters each side and area 156.25 meters squared. Okay, let's continue with part B. In part B, Lola thinks she might be able to make a bigger rectangular enclosure for her lamb if she made use of the existing fences on the farm. One way she could do this is shown in the diagram. The large paddock is square with sides 100 meters long. Investigate different sized rectangular enclosures that use the existing fence. So again, we're asked to investigate, so we want to try different possibilities and make a conclusion from that. So here's the small enclosure for the lamb, and Lola's got 50 meters of fencing to cover these three sides. Okay, the existing fencing, the 100 meter side square, even though it doesn't look very square, is this piece around the outside. Now, there's some possibilities. Lola could make it like this, as shown in the diagram, and we'll look at some of those first. So the area here is x times, now this time I've got x and x, so this must be 50 minus 2x along that side. 50 minus 2x. Now the same as in part 1, I could do that with a table, or I might choose to do it with a graph again. I'm going to try a graph again. So I know that the a-intercept is when x equals 0, so a equals 0 times 50 minus 2 times 0, which is 0. I know that the x-intercepts are where a equals 0, so 0 equals x times 50 minus 2x. So either x equals 0, which means this term is 0, or this term here is 0, this factor. 50 minus 2x equals 0, so 2x is 50 and x equals 25. So let's have a look at that graph. Here's my a-axis and here's my x-axis. So there's an x-intercept at 25, there's an x-intercept at 0. Again, we must have this the vertex must lie on this line that's halfway in between, okay, which is 12.5. When x equals 12.5 for the vertex, A equals 12.5 times 50 minus 2 times 12.5, which is 12.5 times 50 minus 25, which is 12.5 times 25, which must be twice the area of the first one, so it's 156.25 times 2, which is 312.5. So just choosing an arbitrary scale, let's make that 312.5. That will be our maximum where the vertex is. Okay, so the maximum area is 312.5 meters squared, where Lola uses one side of the existing paddock fence and makes a rectangle this time, not a square, with sides 12.5 meters and 25 meters as above. Okay, so she wants it there. Now it said in the question that one way she could do this is shown in the diagram. One way she could do this is shown in the diagram. Well, what's another way she could do it? Another way she could do it is placing her 50 meters of fencing in the corner. So if this is the original paddock as given to us, 100 meters square on the side, if Lola put her 50 meter of fencing in the corner, something like this, okay, so there's Lola's 50 meters, we could make that x, and that would be 50 minus x for that side. Then we can see the area is going to be x times 50 minus x this time. She's used two sides of the original paddock and she only has to build the other two sides. I get a feeling this might actually give a larger area again. So let's see, again with the graph, the A-intercept again is 0. The X-intercepts are 0 and 50 this time. The vertex, well, halfway between the X-intercepts, x is 25 and A equals 25 times 50 minus 25, which is 25 times 25, which is 625. So by putting her fencing in the corner and this time making a square, 25 and 50 minus 25 is 25, Lola will get an area of 625 meters. Lola can get an area of 625 meters squared by making a square of side 25 meters in the corner of the paddock. Oops, and I've just broken my pencil lead. Okay, so let's look at how this question would have been marked. In the first part, remember we want to investigate, so we've got to try different things. Trying two different rectangles, maybe picking a couple and trying them, so we might have done, say, the 5 by 20 or the 10 by 15 and drawing a little picture. That would be enough to get us an achieved mark, as long as we concluded from one of our two which was the bigger. Okay, so we want to try at least two every time. Setting up a table, okay, and systematically going through, noticing that there's this symmetry going on here, and then finding the midpoint of the symmetry and making a conclusion, that would be enough to get us a merit, which is really good. Okay. In terms of getting an excellence for this question, what the markers were really looking for was that step up of using a bit more algebra and a bit of the equation, setting up the equation and then drawing the parabola. So the relationship between the equation and the parabola and working that through, that would get you your merit. So there I'm going to, sorry, not your merit, that would give you your excellence with the conclusion and everything done nicely. So I'm going to give myself a T for that. In part 2, again you could approach it the same as in part 1. Draw a couple of examples, work out the area and make a conclusion on your 2 or 3 examples, and that would give you your achieved, a little U tick. Working through a table like we did in the first one and finding an answer from that, again could get you your merit, as long as you again notice the symmetry and found that maximum area, this time 312.5 square meters. And finally, as I've done here, writing a formula, drawing the graph, okay, would get you your excellence there. Now it didn't matter whether you restricted yourself to on the side or went to in the corner to get your excellence for this. So I would get an excellence for this working through here. Okay, and had I drawn the graph for this last one, instead I would have got it, I can't get double dip and get 2 excellences, but I could have got an excellence here as well. So if my pencil hadn't broken and I chucked in this graph like that, 25, 0, was it 25? Yes, because the X-intercepts, oh no, 50. The X-intercepts were 0 and 50. Grab a new pencil. Okay, 0 and 50, and I had the maximum at 625. Drew a nice parabola. That would have been another excellence there. Okay, so there's plenty of opportunities for achieved merit and excellence in this one, and simply trying a couple of combinations of sizes and doing that investigation could get you your achieved here. But overall I've got 2, so that's giving me an E8.